Hello everyone. Today I am going to talk on pathophysiologic basis of vestibular nystagmus. Suppose this is anterior canal, posterior canal and horizontal canal. Suppose this is utricle, acute and vestibular nerve. So essentially this is vestibular system on the right side. And suppose this is vestibular system on the left side. Now, the vestibular output from both-sided vestibular systems is equal and opposite, and it is convenient to remember the vestibular output from the right side is trying to push the body, the extremities and the eyes towards the left side, and the vestibular output from the left side is trying to push the body, the extremities and the eyes towards the right side. Symmetric equal activity of the vestibular systems on each side normally maintains the eyes in a straight ahead and primary position. Now let us see what happens in acute unilateral vestibulopathy. Suppose the patient has unilateral vestibulopathy on the left side. The vestibular output from the left side reduces and the vestibular output from the right side overpowers the vestibular output from the left side. Therefore, the vestibular system on the right side starts pushing the body towards the left side, and that forms pathophysiologic basis of direction of fall during Bromberg's testing and tandem walking. That forms the pathophysiologic basis of direction of gait drift in walking straight with eyes closed during star walking test, and it forms the direction of pivoting in fuguda stepping test. Now the vestibular system on the right side also pushes the extremity towards the left side. That forms the pathophysiologic basis of direction of finger drift in finger nose testing with eyes closed and pass pointing. The vestibular output from on the right side also causes tonic deviation of the eyes from its primary position towards the left side. This tonic eye deviation towards the left side forms the pathophysiologic basis of slow component of the nystagmus. In an alert patient, this tonic eye deviation to left is detected by left frontal eye field with the help of proprioceptive impulses coming from the eye muscles. The frontal eye field then sends impulses to right paramedian pontine reticular formation. The PPRF is a horizontal gaze center. Now the PPRF sends impulses to the ipsilateral 6th nerve nucleus. The 6th nerve nucleus on right side communicates with the left-sided 3rd nerve with the help of medial longitudinal fasciculus. Then oculomotor nerve arises from the 3rd nerve nucleus and supplies the medial rectus on the left side, and the 6th nerve supplies the lateral rectus on the right side. That leads to corrective saccade towards the right side, and that forms the fast component of the nystagmus. So this is what happens in primary position. There is slow tonic deviation of the eye towards the left side, and the fast corrective component is towards the right side. Now let us see what happens when the patient looks towards the right side. Again there is a nystagmus, there is a slow tonic deviation of the eyes towards the left side, and there is fast corrective component towards the right side. Now here the important point is the amplitude of the nystagmus increases with the gaze in the direction of the fast component. Now the patient is looking towards the right side and the fast component is also on the right side. Therefore, the amplitude of the nystagmus increases when the patient is asked to look towards the right side. Now let us see what happens when the patient is asked to look on the left side, that is towards the side of vestibular dysfunction. Again the same thing happens. The slow component of the nystagmus remains towards the left side and the fast component remains towards the right side. This is called as third degree nystagmus, that is fast component opposite to the direction of gaze, which rarely occurs with any other nystagmus types. The cold water irrigation of left ear or warm water irrigation of the right ear simulates eye movement similar to what described earlier in this video, because cold water irrigation reduces vestibular output and warm water increases the vestibular output. One more important feature of nystagmus of acute unilateral vestibulopathy is it is unidirectional. That is, the fast component always beats in the same direction and is unaffected by gaze direction. This is in contrast to central nystagmus, which is direction changing or bidirectional. In patients with bilateral vestibulopathy, both the labyrinths are diseased or malfunctioning, and there is no imbalance of vestibular output, and hence there is no nystagmus, but patient is severely symptomatic with imbalance of gait. I hope you understood the pathophysiologic basis of vestibular nystagmus. In my subsequent videos, I'll discuss on various types and pathophysiology of nystagmus, especially the difference between central and peripheral types of nystagmus and eye movements during caloric testing.